Okay guys, we've been doing a lot of work on matrices, none of which was put into any context. So it's time to start putting some of this into some context. Okay, we've done a lot of operations, but I haven't really been trying to explain where this all fits to everything we've been doing this year. So we're going to start working that way. So today's title is More Matrix Multiplication, and it is H.09, but this is day 2. Okay, so I just want to talk about how do you take a system of equations and put it into matrix form, because we're going to be using matrices to solve systems of equations. So here we've got a matrix. Okay, let's zoom in a little bit. And what we're going to do, this is pretty easy, is you take all the coefficients. So that's all the numbers associated with variables. Okay, so we've got a 4, a -5, a 3, and a 1. Remember, there's a 1 in front of the y. And you create a matrix out of it. So that's known as the coefficient matrix. Okay? Coefficient matrix. Well, behind that are the variables x and y. So that's the variable matrix. Put your equal sign down, and then you put your solutions, and that's your solutions matrix. Now see, that wasn't that hard. Just grab the coefficients, make a matrix, put the variables in their own matrix, and put the answers in a matrix. Now look, we had an equation, we have an equation, we have an equation, we have an equation. So 2 rows, 2 rows. Okay, you got to keep that in mind. Now I need to convince you of something. How do I know that this, the 4, -5, 3, 1, and then the variable matrix, how do I know that's the equivalent of what's going on this side of the equations? Well, let's try it. Let's go 4, -5, 3, 1, and multiply it by, that's what's going on when you have two matrices next to each other, you're doing multiplication. All right, so we're going to end up with row 1 dot column 1 and row 2 dot column 1. So that's what we're going to do. We're going to multiply these together using that. Okay, so this would equal 4 times x plus -5 times y. Well, that would be just -5y. And then 3 times x plus 1 times y. So you can see if I multiply these two matrices together, I get this. And this is the variable side of the system of equations. All right, let's try another one. This one's called Dancing Queen. Can you guess what the category of the day is? Okay, so a little bit different. I've got solutions over here. They are variables. I have all these coefficients, and I have 3 variables over here. So let's just create our answer matrix, x, y. Okay. Then put an equal sign. Grab the coefficients, 2, 5, -3, 3, -1, and 1. And then you drop down the variables, a, b, and c. Notice that the variables go into a single column. I forgot to mention that. Okay, variables go into a single column. Okay, I've got a you-do for you, Waterloo. So I want you to pause the video and then try it. And here's what I want you to do, though. This time I've given you the matrix version. I want you to write the equation version. So it's backwards. Up here I gave you the equation, and I showed you how to get the matrix version. Here I'm giving you the matrix version, and I want you to write the equation version. Do this as a you do. So go ahead and pause the video right now. Okay, hopefully you did pause it and you've come back with the answer. You should have this. X equals u plus 2v. Y equals 3u plus 4v. And z equals 5u plus 6v. Hopefully that's what you got. All right, one more page. Now, this one, what I've got is I've got an equation for A that is in terms of P and Q. A equals 3P plus 7Q. But over here I've got P in terms of X and Y. P equals 2X minus 3Y. And I've got Q in terms of 5X plus 4Y. And what I want to do is I want to take and write an equation. I'm going to take all this and write an equation that has A expressed in terms of X and Y. So really what I'm doing is I'm taking and substituting in for P 2x minus 3y and substituting in for Q 5x plus 4y. Okay, I'm not going to color code this because that just got too complicated last time. So I've got A equals 3. Now instead of P, I'm going to put 2x minus 3y plus 7. And instead of Q, I'm going to put 5x plus 4y. So this equals 6x minus 9y, distributing the 3, plus distribute the 7, plus 35x plus 28y. And then we can combine the like terms. And let's do this the hard way, okay? Let's go ahead and rearrange, put the x terms next to each other. Minus, let's go plus a negative 9y plus 28y, okay, equals 6 plus 35x plus negative 9 plus 28y. So our final is 41x plus 19y. Okay, so all I did was I rewrote the equation for A in terms of X and Y. Got it? Now let's look at a different way of doing this, okay? A, matrix A, is going to be the coefficients of this equation. So 3 and 7. Okay? Really, what I've got is, here are the A coefficients, and I've got the P and the Q. So in equation A has a 3P, and there's a 7Q. See the 3P and the 7Q? B is going to be the matrix. Okay, so now I've got the P and the Q, but our variables over here are X and Y. So the X in the P equation is 2. The Y in the P equation is negative 3. The X in the Q equation is 5. And the Y in the Q equation has a 4. So I've got these two matrices. Now, watch what happens when I multiply these. AB equals 3, 7 times 2, negative 3, 5, 4. Okay, so what we're going to end up with is row 1, column 1, and row 1, column 2, dot products. That's going to be my matrix. Okay, so it's going to be row 1, dot product with column 1, and row 1 dot product with column 2. So here we go. You ready? We've got 3 times 2 plus 7 times 5. And then you've got 3 times negative 3 plus 7 times 4. Okay, so now you got 6 plus 35 and negative 9 plus 28. Those numbers should start to look familiar to you. And what we end up with is 41 and 19. Okay? Now, those are the coefficients we saw up here when we had an equation for A in terms of X and Y. All right, so that's how you can change an equation to